Okay. Our next theorem is the theorem of Pythagoras. Now for the exams, this proof is not, you don't have to know the proof of theorem 3, 4 and 5, only 1 and 2. Okay, we all know Pythagoras. It says that the hypotenuse squared equals the two other sides squared and added. Okay, so that is Pythagoras. But if you have a triangle with a 90-degree angle, and from that 90-degree angle, you draw a line perpendicular on the hypotenuse, then the following is true. Okay. So there's my triangle. Now you have to look here. I'll give you time to copy this page, but it's important that you understand it and see the patterns. So I have a right-angled triangle, and from the right angle, the 90-degree angle, I draw a line perpendicular on the hypotenuse. Now, the normal Pythagoras says BC squared equals AB squared plus AC squared. We all know that one. Then we have another one. If I ask you what is AD squared, it will be BD times DC. Not squared, only times. If I ask you what is that squared, then it is BD times BC. If I ask you what is this squared, then it's DC times BC. Okay. So these you need to know. They are those on your paper. Okay, but it's easier to remember these drawings. So I'm quickly gonna let you draw the triangle. It's that triangle, and then if I ask you what is AD squared, you know it's the bottom half's product. If I ask you what is AB squared, you know AB is part of the green one, so it's the green base, but AB is also part of the big one, so it's the big one's base. BD, BC. If I ask you what is AC squared, AC forms part of that triangle, so it's that base times, but it also forms part of the big one times the base of the other one. Right, quickly copy these. I'll shift it up as you go on. Quickly copy these.
Is the reason for all of them Pythagoras is the reason?
Yes. Yes. The reason is Pythagoras. These pictures are not on your page, so you have to copy them. Okay, I'll shift it up. Can I go on? No. Everybody done? Okay, the three pictures that you need to know. And they are all proportions. It's BD times DC, and on the left hand side it's actually AD times AD, so it's a proportion. It's only you. It's you, it's you, it's you. Okay, can I carry on? You're still busy? Okay. Who's still copying? Okay, if we look at example 1, they say that you have a triangle ABC, so it's the big one, and C is 90 degrees. CD is perpendicular on AB. What do you know immediately? Pythagoras, and we can use those three pictures. Okay. Also, is DF perpendicular on DF perpendicular on AC, and DE is perpendicular on BC. So all these perpendicular lines actually comes from a 90-degree angle. Okay. Now they ask, why is the yellow triangle similar to the pink one? And we are going to use Pythagoras for similarity. Okay, now you will say, and you have to answer all these questions in this way. In triangle DBE, angle D is 90 degrees. It's given. I think there is a mistake here. That should be DBC. Sorry. In angle DBC, angle BDC, that big one, is 90 degrees. Also, this angle DEB, this yellow angle, is also 90 degrees because the perpendicular line comes from angle D, which is a 90-degree angle. Therefore, angle DBE, the yellow one, is similar to angle CDE, the pink one. Okay, so to get back to my three pictures, when using Pythagoras, it means that this small triangle is similar to that small triangle. And this left triangle is similar to the big one. And the right that small triangle is similar to the big one. Okay, so all of them are similar. And what is the reason for that?
Well, the Pythagoras one do they need to have a common a side where they're all touching or
Yes, it must be one big triangle from where you draw the perpendicular line from the 90-degree angle to the hypotenuse. So it's inside the big one. If you use Pythagoras to calculate side lengths, your reason is Pythagoras. But if you use these, then your reason is there's a perpendicular line from the 90 degrees to the hypotenuse. So that is why the yellow triangle is similar to the pink one. Any questions? Okay, the next one. Now you have to complete those. We are looking at the blue triangle, BDC. Now they ask DB squared, so it's this one on the left. That will be equal to what? BE times BC, very good. DC squared is that one. That will be equal to CE or EC times CB. The third one is the middle line. That will be equal to Xavier?
E times EC.
No, not a D. BE times EC. Yeah.
That's what we said.
Now I hear a D from this side.
What, two?
Now they ask, why is DC squared, that one, equal to CF times CA? Why? Why is this line squared equals to that times that? Yeah, you first have to prove. In angle ICDs, please. So it's the top right big one. The big angle D is 90 degrees, that's given. And from that 90 degrees, we get a perpendicular line. That means that angle DFA is also 90 degrees. Therefore, angle ACD, the big right one, is similar to angle DCF, the left hand of that big right one, or the bottom part of the big right one. The reason is there's a perpendicular line from 90 degrees to the hypotenuse. Do you all follow?
Now instead of writing GF is perpendicular to AC, you just write given.
No, it's not really given that it's 90 degrees. It's given that there's lines that are perpendicular. Okay? Therefore, because we need DC and DC, so there's DC and DC, and CF and CA, CA and CF, so it's two birds, we can write this proportion. Then cross multiply and you get what they ask. So if they ask this type of question where you know you're working with the Pythagoras triangle, you first need to prove similarity and you then use that to get the proportions, cross multiply and get the answer. Any questions? Okay, now question D of example 1. They ask prove that BD over AD equals BC squared over AC squared. It's on the right hand side. Okay, so we start with in triangle ABC, we have that angle D, ADC, that one is 90 degrees, because we have a perpendicular line from the 90 degrees. CD perpendicular on AB. Also, yes. Now you must give the big one because angle D has a lot of angles. Also, the big angle C is 90 degrees, that is given. Therefore, angle ABC is similar to ACD, is similar to CBD. The reason is there's a line from the 90 degrees to a perpendicular line from the 90 degrees to the hypotenuse. Perpendicular line Now we are going to use the big triangle on these two small ones and the similarities to prove that. Okay, so we start with AC squared and BC squared. AC squared equals AD times AB. BC squared equals BD times AB. Now you just put them on top of each other with their multiplications. Cancel out and get your answer. Do you all follow? Yes? No? Okay. Example 2. They say that that big picture is a kite. So you have to know all the properties of a kite and fill it in on your picture. We know that a kite has two adjacent sides that are equal. So those two. We also know that this diagonal divides that angle O into equal angles and this one. We also know that the diagonals bisect 90 degrees and that the long diagonal bisects the other diagonal. Now they ask, why is this yellow triangle similar to the green one? Why do you think? Okay, there's an easier one.
The OCD is 90, and the other 90.
Yes, there's a line CD coming from the 90-degree angle and it's on the hypotenuse of the big one. Okay, so what's what it say? In angle OAC. Okay, ek gaan sorry. The space is a little bit limited there. So, in the big green triangle, the big C angle is 90 degrees, it's given. Then angle D1 in the yellow one is 90 degrees because of a diagonal of a kite. Therefore, we have a perpendicular line from 90 degrees to the hypotenuse, and that makes the two triangles similar. Now they ask you to complete those three. So OC squared will be equal to OA times OD, or otherwise okay, complete the other two. is analytical and Euclidean, grade 11 and 4. Pardon? Ik kan niet worden. Our exam, the one that we're writing, the pre-limit term, is it also going to be like grade 11 and 12? So what's not in grade 11 and 12? Like the theorem. It's all those theorems at the beginning of your Euclidean batch. You have to have that. I'm seeing the students from last year. Okay, let's carry on. CA squared will therefore be OA times AD, and CD squared will be OD times AD. Now they ask, prove that BD squared over OB squared equals AD over OA. First, you need to say that in triangle AOB, the bottom big one, we have the big B is 90 degrees, given, and angle D is 90 degrees, diagonals of a kite. Okay, this board is double. So we just stated that we have a Pythagoras triangle with a 90 degree and perpendicular line from the 90 degree angle. Now we can use Pythagoras' proportions, BD squared and OB squared, and put them on each other, cancel out, and get your answer. So if you want to use those three pictures, you always need to say this first.
After you say the reason, or before, don't you need to say which triangles are similar?
You don't have to.
I don't have to.
You don't have to.
Are you like?
No, you really don't have to.
You don't have to.
In this case.
Yes. Okay, can we carry on to the next one? Who's still busy? Are you done? So for number 2, they ask you, your homework is exercise 5, number 1 to 5.